Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are looking at our 12th video in our series on solving simultaneous equations graphically as part of our advanced algebra playlist. Let's get straight into it. Now there is some prerequisite knowledge you should be aware of before embarking on this video. Firstly, you need to know how to draw a graph using a table of values. Okay, that's pretty basic year 7 stuff, but you should be proficient with that. Secondly, you should be able to graph using equations in the form of y equals mx plus c. And once again, this is year 9 work, so hopefully you'll be able to understand how to do graphing using an equation in that form. Thirdly, you need to know the gradient and the y-intercept, what that means. What is a gradient? What is a y-intercept? We don't have time to go into that into this video, so hopefully that is knowledge you already have. And just basic graphing principles, things like that you should have titles on your x-axis and your y-axis, that you need to use a ruler, that you need to scale properly when you're graphing. So these are things that I'm hoping you understand, and we'll get straight into it with a very brief linear relations recap. So you would recall that a linear equation, linear comes from the word line, and it graphs as a straight line. So for example, when you see an equation that looks like this, y equals 3x plus 2, it's a linear equation and it is going to be a straight line when it's graphed. This is what it actually looks like when it's graphed. So as you can see, straight line. Okay, now we can describe a straight line by key features such as the gradient. The gradient is how slopey the line is. Is it a steep slope, or is it a slope that points this way, or is it a slope that points that way? That's our gradient. We've also got something called our y-intercept, which is where the line cuts through our vertical axis, the y-axis, and it's cutting through in that spot there. Intercept means to pass or to connect. So if you're intercepting football, you're connecting with the person who's got the football. So that is our intercept right there. Okay, we can also describe a line using its x-intercept, and our x-intercept is down here where it connects with the horizontal x-axis. Okay, so that's a bit of a recap of linear relations. Now thinking about that straight line is made up of an infinite number of points all the way through to infinity, connecting all through every single number. So therefore there is an infinite number of x and y coordinates that sit on that line, and we describe those as ways that could solve that equation, y equals 3x plus 2. So for example, if we know that x equals to 1, then we can work out what the value of y is. Or if we know what y's value is in a particular part of the line, we can work out the x value and so on. Now let's talk about two lines, because this video is all about simultaneous equations, simultaneous meaning at the same time. So two straight line equations that exist on the same graph. Now when we've got two lines that aren't parallel, they will cross at some point. We can see down here that these two ones here are intersecting or crossing over each other at a single place. Now each of those two lines has unique equations. As you can see, the red line has the equation y equals 3x plus 2, and the blue line has the equation y equals x minus 1. And I'm using Desmos graphing software today to demonstrate these principles. Now this single point of intersection is the only place on the line where the lines will cross, and it will share a unique set of coordinates. In this case, that coordinates are the x value is negative 1.5 and the y value is negative 2.5. Now, because there's only one point on both lines that will be true where both lines cross over, we can actually substitute negative 1.5 and negative 2.5 into both equations and they will both be true. So for example, negative 1.5, if you multiply that by 3, you get negative 4.5. Add positive 2, you get negative 2.5. So that's our y value there. And you could do the same thing down here. Negative 1.5, take one more away, you get negative 2.5. So this set of points, x and y coordinates, when you substitute it into both equations, it'll both be correct. It's called satisfying or solving both equations. Okay, so to recap, in order to solve simultaneous equations, both equations can be graphed, and that point of intersection is going to be the solution. Now, you can use algebraic techniques without graphing. We're going to do that in our upcoming 2 videos. But for today, we're using graphical techniques in order to find that point of intersection. Now, this is only going to work if you can graph accurately and precisely. If you're a terrible grapher and you muck things up and you can't use your ruler properly, it's probably not going to be a precise solution. That's going to be a problem for you. Also, this technique only works if you can read off a graph accurately and precisely. If you can't do either, then you're going to want to brush up on your algebraic techniques or learn how to graph precisely and accurately. So let's have a look at our first example. We need to solve these 2 equations, y equals x plus 2 and y equals negative 2x, take away 7. So we're going to be using a graph to solve these 2. Like I said before, we could use algebraic techniques, but this video is all about graphing. Okay, let's start with that first equation, y equals x plus 2. So what I'm going to do in this first example is use a table of values. When I'm using a table of values, what I'm going to do is find up to 4 points that I can graph. The more means I get a more accurate line. Okay, so sometimes when I only use 2 solutions, my graphing can be a little bit off depending on how big I've drawn my dots, but the more the merrier. Okay, so what we're going to do is we're going to substitute x equals 0 into this equation. We're going to get a y value. This will give me 4 sets of coordinates that I can use to plot my first graph. So putting in 0 for the x value, 0 plus 2 gives me 2. Putting in 1, 1 plus 2 gives me 3, and so on for my final 2 solutions. 4 and 5. So now I've got some graph paper and I'm going to graph this particular equation. Now, first of all, before I get started, what I want to do is I want to put in an x-axis and a y-axis. Okay, I want to label those up as well using a ruler. Okay, the next thing I want to do is put my numbers on the graph. Okay, now make sure that you space these out evenly. It's called correct scaling. So it doesn't have to go up in 1s, it could go up in 2s or 3s, but whatever you do, make sure it's consistent all the way along. Okay, so now I'm going to plot my first point, 0, 2. 0 is my x value, that means I'm coming along 0 places, so I'm staying on that axis, and I'm going up 2, so that's my first point there. My next point is the point 1, 3, so I go across 1 and up 3. And then my next point is the coordinates of 2, 4, and then 3, 5. So now I've got 4 points all plotted, and I can see really clearly that when I draw the line, I'm not going to be drawing it across the tops of the dots or the bottoms of the dots. I'm going to be going across these middle sections here so that I exactly hit where the 2 lines of the grid paper cross over. Okay, so I can take those dots away now. Make sure you also label your line with the name of the equation that it belongs to, because you're going to have 2 lines, so they need to be labeled clearly. Okay, so now we've actually drawn our first equation. It's time to do our second one. Now I could start with the same numbers I used for my first equation, 0, 1, 2, 3. What that's going to do is give me lots of really negative values. For example, if I put 0 in here, I get negative 2 times 0, makes 0 minus 7. Now if we look at our graph, what that's going to mean is I'm going to have a point all the way down the bottom here, and the bigger that my x value gets, I'm going to need more down this end. So I'm just planning a little bit forward here. If instead I started with some negative numbers, okay, for my x values, that means I'm going to be graphing along here, and that means I don't need to extend my graph all the way down to the bottom of the graph paper. It's just a little bit of forward thinking. Although this is really important when you're working with substituting negative numbers, be really careful. So I've got negative 2 take away times negative 2 makes positive 4, take away 7 makes negative 3, and then I'm going to put those other values in here, and I'm going to get 3 more sets of coordinates. Now what I need to do now is label down the bottom of my graph, and I can start plotting in some points. So I've got the point negative 2 and negative 3. That's my first point. Negative 1, negative 5, and 0, negative 7. You can see why I didn't want to extend further down with more positive numbers, because I was going to go below the grid paper, which would not have been good. Okay, so we're going to draw that line in and make sure we label our graph. Now we can see there's a point of intersection where both lines are crossing over. Reading off the graph, I read it crossways first, so I've got -1, 2, 3, so -3 is my x-coordinate, and then down 1 is -1. So that's my point of intersection, and it is the point that solves the two equations. Now I can check that by substituting that back into my original equations. If I take this coordinate here, -3 plus 2 gives me -1, so yes, it works for the first equation. Let's try it here. -2 times -3 is +6. Take 7 away, I get -1. Yes, I've solved it. So that checking is always really important. So that's our check there. And if you're going to do a check on your actual exam paper like I've done there, make sure you just write above it, check, so your teacher knows what it is you're doing and that you're not creating a second solution there. Okay, let's now try a different example. Now, instead of using a table of values this time, we are going to graph using intercept and gradient method. Okay, so first of all, we're going to start with equation 1. The y-intercept, if I read that off here, is just +2. The gradient is -3. Okay, and that means that for every 1, remember, gradient is rise over run, so it's going to drop 3 because it's negative for every run of 1. I've got to get my language correct. Okay, so let's draw that here. So what I've got on here is my graph. I've already put in my x and my y for my axes. I've already numbered off everything. Okay, so first of all, what I need to do is find my y-intercept on the graph. That is right here at point 2. Now this is where people make mistakes. They think rise and run goes from the origin, which is here where the two lines cross over. That is not correct. We rise and run from our y-intercept every single time. So it's -3, so that means we're going to drop 3, which will take us down to -1, and then we're going to run 1, which is where our second point is. Now we've got 2 points. Very carefully, we're going to place a line between the two of them, making sure that it passes through that little cross there and that little cross there, and making sure we label our line that we have drawn in. Now it's time for our second equation. Having a look up here, I can see that I have a y-intercept of -8 and a gradient of +7, and what that means is rise over run. I'm going to rise 7 for every run of 1. It's going to be quite a steep graph. So first of all, I'm going to place my first point down at the y-intercept -8, and then from -8 I'm going to rise all the way up to -1 and then run 1 here, and that will be my point of intersection as well. I can see that straight away off the graph, label that graph up, and there is my point of intersection. Now that means that the coordinates there, I'm going to be going across -1 and down, so the coordinates are +1, -1. Okay, so sorry I said that was negative a moment ago. It's +1, -1. So reading really carefully your coordinates off the graph. And once again, you can check your work. So firstly, substitute in x and y into each equation. So -3 times 1 makes -3 plus 2 makes -1. Yes, I've satisfied that first one. And secondly, I'm going to ask myself, does -1 equal 7 times 1? 7 times 1 is 1. Take away, sorry, 7 times 1 is 7. Take away 8 makes -1. Yes, I've got the solution. Well, did you find this video helpful? I sure hope that you did. And if you did, here's some ways you can engage further. You can like and subscribe, hit that notification bell so you'll always know when our next video is ready to view. You could tell someone about this video or even tell us in the comments. Always love it when people do that. And you could also super like the channel, which means giving a small donation to thank us for the hard work that we've put in for your benefit. And you can look for us on social media. Facebook and Instagram is where we are at. If you've got any questions at all about anything you saw in this video today, mcclutchymaths@yahoo.com is the place to go. Now, if you're wanting to know more about those algebraic techniques, jump onto the next 2 videos, solving using substitution, solving using the elimination method. These are the ones that are expected of you more in grade 10 and 11. And the advantage of those is that graphic techniques take a long time and they do require that precision and that accuracy. So if you've got good algebra skills, that is a far quicker way to do it. Well, thank you so much for watching today. I'm Natalie McClutchy. Have a wonderful day.